Okay, this is going to be our last video for the lipid chapter, and we're going to end it with saponification, which is one of the reactions of lipids. But before we do that, let's take a look at something here. This is a triglyceride, okay? What if I asked you, is it a mixed triglyceride or is it a simple triglyceride? You can immediately see that the fatty acids are not the same. So it's a mixed triglyceride. Can you see that these two are saturated and this one is unsaturated? If I ask you, is the unsaturated one monounsaturated or polyunsaturated, you would say obviously it's polyunsaturated, right? What if I ask you to identify the fatty acids? What do you have to do? You have to count the carbons. So this is carbon 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. What is a 14 carbon saturated fatty acid? That was myristic acid. Myristic acid. Then you look at this one. Carbons 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 carbon saturated fatty acid. This is lauric acid. And then I come to this one. All right, I know it's polyunsaturated, so let's see where the double bonds are. So carbons 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, between 9 and 10, 11 between 12 and 13, and then 14, 15, 16, 17, 18. So 18 carbon fatty acid with 2 double bonds. What was it called? This is linoleic acid. So this one is linoleic acid, not to be confused with linolenic acid. Okay, what if I asked you, are there any essential fatty acids in this triglyceride? You would say, absolutely yes, because linoleic acid is an essential fatty acid. Then what if I ask you, is there an omega-3 fatty acid or is there an omega-6 fatty acid in this triglyceride? How would you figure that out? Well, you know that omega-3 and omega-6 have to have double bonds, and you count the double bond from the end. So this one goes 1, 2, 3, 4, 5, 6. Since the first double bond is at carbon 6 from the end, this would be an example of an omega-6. Okay, so that's a quick recap of some of the things we've done in the videos that we've done before. But right now I want to talk about saponification. What is saponification? It's breaking the ester bonds with a base. So before we just broke the ester bonds with water and some catalyst, but now we want to break the ester bonds with a base. And bases, if you remember intro chemistry, they're the strong bases are the group 1A metal hydroxide, sodium hydroxide, and potassium hydroxide. So we're going to use NaOH, but we could also use KOH. All right. So what happens? We're going to need 3 sodium hydroxides. Okay. And what you end up doing is you break this and you make this part charged. This becomes glycerol. So the products of saponification are glycerol is one product, and then you get 3 soaps. You're going to have 3. They sometimes call them salts, fatty acid salts, but those fatty acid salts are soap. That's what a soap is. So let's take a look and see structurally what is going on. You're breaking this, breaking the ester bond, so you end up with a glycerol, just like we did with hydrolysis, exactly like with hydrolysis. But then the next part is not like hydrolysis. Let me show you what happens in the next part. So you're going to have this is what's going to end up happening. This becomes a charge, and this is a charge. So you have this charged part. This, again, you're getting a charged head, and then the rest of the molecule looks the same. So this was myristic acid, so carbon 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's your myristic acid. And then the next one, same thing. Sodium ion and the carboxylate ion. Here you have this. And then you're going to have lauric. So carbon 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then the last one, same scenario. You have a charge, so it's not a carboxylic acid anymore. It's called a carboxylate ion. Remember from intro chemistry, ions are things that have charges. Anything that has a charge is an ion. And then we have this sodium ion. And then this is carbons 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so we just created these three here. These are called salts, fatty acid salts, but a fatty acid salt is also a soap. So the products of saponification are glycerol and 3 soaps. What are the names of the 3 soaps? Now we have sodium myristate and sodium laurate and sodium linoleate. And if you look at ingredients of soaps or detergents or shampoos, you'll see, you might see sodium stearate or sodium palmitate. These are all names of soaps. How do you make soap? You get an oil with a bunch of triglycerides in it, and you boil it with sodium hydroxide, and what do you end up with? You end up with glycerol and soaps. So how do these soaps clean your hand? Like, think about this. Let's say, so again, be able to recognize soaps, be able to recognize saponification, be able to name these soaps, because the minute you end up changing the name. So instead of myristic acid, now it's sodium myristate. Instead of lauric acid, it's sodium laurate. Instead of linoleic acid, it's sodium linoleate. Or at least be able to recognize those names as names of salts. Names of soaps. I apologize. All right, so let's say this is your hand. Remember, I'm not an artist, okay? And here's some oil on your hand, a droplet of oil. Actually, try it out at home. Put some butter on your hands and then go try to wash your hands with just water. The butter won't come off. It just won't come off. Why not? Because the butter is very non-polar, hates water, and the water hates the butter. Water is polar, hates anything that's non-polar. So there's no way that butter is going to come off, or oil or whatever. So what do? You wash it with soap. What does the soap do? So remember when we were talking about the emulsion and the eggs and baking the cake? It's the same type of concept. Let's take this little oil droplet, put it over here. So what's going to happen? Remember, this is all water out here. This is all water, all right? And this is your oil droplet. Your soap is going to come in and get the water and the oil droplet or the butter together. How will it do that? Which part of the soap is attracted to the water? Remember, we said like dissolves in like. Polar likes polar. Non-polar likes non-polar. So this part over here, that's the polar head. So the polar head loves the water. This long tail of the fatty acid likes the oil droplet. So we draw the head towards the water, and then the tails, I know that's just a zigzag line here, pretending here. And so the oil droplet is surrounded by soap molecules where the polar part that has a charge is attracted to the water, and the non-polar part that hates water is attracted to the oil. And then once that happens, it can lift that oil droplet from your hand and it gets washed away in the water. And I want you guys, every time you are washing your hands, especially if it's trying to get some grease or anything oily off of your hands, think on a molecular level. Now you know what is actually going on. It's pretty cool. Biochemistry is so relevant to your everyday lives, guys. There's so much more to lipids, honestly, and just like even with the carbohydrate chapter, so much more. But I don't want to overdo it and I don't want to overwhelm you. So make sure you know everything from the lipid chapter, carbohydrate chapter, organic reactions, and organic compounds. All that is going to be on your midterm. And then we get started with the protein chapter. I'm a protein chemist, love proteins. They are my favorite. I shouldn't have favorites. I love it all. All right, I will see you in the next video.